Greedy algorithms. Greedy algorithms is a class of algorithms that makes locally optimal choice at each step, hoping to find the global optimum solution. What does this mean? This means a greedy strategy, a greedy algorithm will always work step by step. That is, it will make the final solution step by step. And what does it do in each step? In each step, it does whichever option looks the most lucrative or the most immediately promising. That is what it is going to do. This is something like living in the present. That is, you don't care about whatever is going to happen in future. You don't care about whatever already happened in the past. At the present moment, what makes you the happiest or what gives you the best output? That is what you are going to do. This is greedy strategy. Let us say you are running a 100-meter race. If you are running a 100-meter race, what will be your strategy? The aim is you want to win the race. So if you want to win, you should be faster than everyone else. So how will you strategize? What you will do is at each second or at each point of time, you will try to put all your energy, all your strength in so that you can be the fastest at that point. So at the first second, what will you do? You'll try to be the fastest among all your opponents, all the participants in the first second. Similarly, in the second second, what will be your strategy? The same. You will try to be the best among all the participants, the fastest among them, so that you can have a lead over others. The same thing you will continue for every single second. That is, at every point of time, you will be trying to be greedy. You will try to maximize your profit, maximize your efforts so that you can be the fastest in this race. And the end of the race, let us say 100 meters was completed in 15 seconds or something. And by that time, if you want to be the winner, the best idea is to try to be the winner in every single second. So if you are the fastest at every single second of the race, automatically at the end of the race, you will be the fastest and you will become the winner. This is the greedy strategy. At every point, try to be greedy. Try to maximize whatever you can gain. But there is a problem with this strategy. The problem is sometimes this greedy algorithm works, and when it works, you are guaranteed of the optimum output. You will be the winner. But in some cases, this will not be applicable. And when it is not applicable, you will fail to get optimum output. Let us take an example of a marathon. Instead of a 100-meter race, let us say you are running a marathon this time. So marathon is more than 42 kilometers. So when it is more than 42 kilometers, the total distance to be run, what will happen if you use the same strategy? At the first second, you are trying to go all out. You are trying to put all your energy, all your strength to be the fastest at that second. Second also, you are doing the same and so on. At every single second, what will happen? You may manage to continue this for the first 100 meters or maybe for the first 200 meters. Or if you are very athletic, maybe you will manage it for the first 400 meters. But after that, you will get tired. You won't be able to put all your strength or all your efforts, and slowly your speed will decrease. And what will happen? Leave the concept of winning this marathon. You may not even manage to complete this marathon. That is what happens if you apply greedy strategy in this marathon race, because here you have to cover much larger distance, which is more than 42 kilometers, and because of which you have to strategize it differently. So this is a case where your greedy strategy doesn't work. Same case in case of algorithms. As a programmer, you should always have greedy as your go-to strategy. So if greedy works, that is the best strategy for you as a programmer and you are guaranteed of the best output. Moreover, your algorithm will be faster and it will be easy to implement. But you have to be careful that this should be an algorithm where greedy is applicable. In some problems, greedy will not be applicable, and if you try to apply greedy there, you will fail. So the next question is, how do you identify that for one particular algorithm, greedy strategy is applicable or not applicable? This is the big question. So there are two properties that you have to look for. If both the properties are satisfied, that means you can go for greedy strategy. If either of these two properties are not satisfied, that is, if first property fails or the second property fails, then you should not go for greedy and you should look for some other alternatives. Let us see what are the two properties that you have to be careful in order to decide whether greedy is applicable or greedy is not applicable. So the first property is called greedy choice property. What does the greedy choice property say? It says choosing the best option at each step will lead to the best overall solution. Or in other ways, you can say each decision that you make at any step is made without reconsidering any of the previous step, or also without considering whatever you are going to do in future. So greedy choice property, it says choosing the best option at each step will finally lead to the best overall solution. So basically, this talks about the greediness. If you show greediness, you'll be able to succeed in solving this complete problem. This is what greedy choice property says. And what is the second property? Second one is optimal substructure. Optimal substructure property says you can break the problem, which is a larger problem, into smaller subparts. So this is the substructure of the problem. You can break the larger problem into smaller parts, and then solving each of these smaller parts separately using the greedy strategy will solve the overall problem. So what is the difference between these two properties? The first property, which is the greedy choice property, it talks about the greediness. It talks about taking the greedy approach at each single step while you are solving. That will lead to final best solution. That is what first property says, while the second property talks about the problem being breakable to smaller parts. That is the substructure of the problem. Because of this optimal substructure, you are able to break the larger problem into smaller parts. See, only if you can break into smaller parts, after that only applying greedy approach in each of those smaller parts makes sense. So these are the two properties. When we go into deep lectures on each of the greedy algorithms, we'll see how these two properties are maintained in all those problems and how you can apply greedy strategy in those. So coming to greedy algorithms, next thing we have to see is how can you go forward applying a greedy strategy to a problem. Let us say you already checked for both these properties. You know that greedy choice property is satisfied. Optimal substructure is also satisfied, which means you can go forward with the greedy strategy. So the next question is, what are the steps to be followed while following the greedy strategy? So the steps to be followed are like this. Initially, you are at the starting state. Let us say you are at this starting state. What should you do next? You should evaluate all the possible choices from the present state and then choose the one which is the most lucrative or the one that is giving the best output for you at this particular present state. So let us say you are at this present state. What is the second step? You should see for all the possible choices to which you can go from this present state. Let us say you have all these four choices. What should you consider? You should not think about whatever you already did or whatever you are going to do. The only thing is, at the present step, if you choose first choice, second choice, third choice or fourth choice, whichever gives you the maximum output in this single step, that is what you're going to choose. This is the greedy strategy. So initially you started with an initial state, you checked for all the possible states to which you can move from this initial state, and you're going to choose the one which is giving maximum output or maximum profit. Let us say this state is giving you best output at this particular point of time. What will you do next? You will move to this state, which is your second state, and then continue the same strategy. You will see for all the possible states to which you can go from this state, and whichever is the most lucrative one, the one which is most immediately promising, that is what you're going to choose. So you are going to repeat this same step again and again till you reach the final solution. This is what greedy strategy is all about. So coming to this greedy strategy, there are many standard algorithms that follow greedy strategy. We'll be going to all of those one by one. So as of now, let us just see what those are. One is fractional knapsack problem. This is a very famous problem which can be solved by greedy strategy. Another one is activity selection problem. Similarly, you have job sequencing. There is Huffman encoding. You have many graph algorithms as well. Something like maybe Kruskal's algorithm is the, Dijkstra's algorithm is the, Prim's algorithms is the. So all these belongs to greedy category or the greedy paradigm of algorithms. In the coming lectures, we'll be going in deep into all of these. So at that point, it will be clear for you how greedy strategy is applied in all of these algorithms. Before we conclude this lecture, one more thing to look into is what are the advantages of using a greedy algorithm and what are the disadvantages of using greedy algorithm. What are the advantages? The first advantage is that greedy is usually faster. So if you compare with any other algorithm, greedy algorithms tends to be faster because you can make quick decisions at each step. The only thing to consider is whatever is the best for this particular point of time. You don't have to see for anything else, because of which your decisions will be quicker and you will reach into the final solution faster compared to other algorithms. So this is the first advantage of greedy strategy. Second advantage is generally greedy algorithms will be easier to implement. That is, when you compare with other algorithms, something like, let us say, dynamic programming, or if you compare with backtracking, in these cases greedy algorithms will be easier to implement as a programmer. So as a programmer, both these are to your advantage. First thing is that your algorithm will run faster. Second thing is that it is easier for you to implement. So from both sides, it is a win-win situation if you are using greedy strategy. Because of this, as a programmer, always greedy should be your go-to strategy. If greedy doesn't work, then only you should think of other strategies. What are the disadvantages of a greedy algorithm? Disadvantage, first thing, is that it do not always yield the optimal solution. So sometimes it may give the optimal solution. In some cases, those problems cannot be solved by greedy algorithm and it may not give you optimal solution. So not all problems can be solved by greedy approach. And how will you decide this? You will decide this based on the two properties that we discussed. Accordingly, you can decide whether greedy is applicable for this problem or if greedy is not applicable. In the coming lectures, we'll go into each of the greedy algorithms and we'll see how greedy is applicable there and how greedy approaches solving the problem.